Cool. So pretty much everything I'm going to talk about today was learned somewhere along the line while I've been making PixieJS. And once I've talked about something, if it's relevant, I'll just sort of explain how to do it with PixieJS. Okay, cool. So first thing I'd like to talk about is blend modes. Something nice and easy to start off with. So I'm pretty sure everybody knows what blend modes are. In the simplest form, a blend mode is how one image is, one image is blended over another. So even if you overlap two images, that's still, blending, but that's the boring kind of blending. What I want to talk to you guys about is sort of the cool new sort of blending that's coming in. So why do you want to use blend modes? Well, basically designers love blend modes. Tell a designer that he can have his blend modes back and he'll be your friend for life. They basically add a really nice layer of fidelity that can really sort of help a creative treatment pop, and anyone who uses Photoshop or Flash will know the value of them. So here's an example of some blend modes in action. Okay, cool. So here's some ghosts. They don't actually have any blend modes at the moment, but if I click the mouse, there you go. So that's basically the add blend mode. So already it's like made the little ghosts, especially when they overlap, they look a little bit more interesting. If I sort of click through, I can show you a few different ones. Lighten. Yeah, cool. Yeah, that one's not so nice. But yeah, that's probably the best one. Yeah, so you can see it, kind of really adds an extra dimension to just flat 2D stuff. So what's the lay of the land with blend modes? So basically the good news is they exist. They do exist in CSS, but in a really limited scope. In Canvas, they're actually in a really good place. So you can thank Adobe for that, because they basically created a spec for a little while back. And not only have the majority of browsers actually implemented the spec, they've basically implemented it, so it exists. And the list of blend modes is here. So there's actually quite a few. Not every browser supports every single one, but there's still, like most browsers will have enough to keep you happy. So okay, so how to use blend modes in Canvas. So yeah, it's pretty basic. I mean, do you guys know are you guys quite familiar with the canvas and the context? Cool. Okay, right. It's super simple then. So we want to draw an image. You basically have an image, you draw it, bam, goes onto the canvas, and then you just change the global composite operation. So if you change it to, the typo there. But anyway, take the V off there. But you set it to invert, and then you basically, when you draw your next image, it will basically get blended in a much more interesting way than basically the default, which is source over. The only major browser that doesn't fully support blend modes yet is IE, but it does have one, which is the lighten blend mode, and it's really similar to add. So I've got an example of the add blend mode, because even though it's only one, it's still quite a nice one to have. That'll be this one here. So this is basically some lasers with a lighten blend mode. Far up now. Cool, there you go. So basically the cool thing is about this example is that this will run on everything with a canvas, and it will look exactly like that. So you'll get that really cool white burnout on everything. So all mobiles, IE9, IE10, Chrome, Firefox, which is really nice, because it means that if you use it, it will actually work. Cool. So webGL blend modes. So this is a bit more of a mixed bag. You do have blend modes, and you do have shaders. So obviously you could create a blend mode that does pretty much whatever your brain could think of. But the cool thing is you basically get add, multiply, and screen for free, because they sort of work off the GL blend property, which basically means you don't have to actually write a shader to use them. You can just go, right, use these blend modes, or you just tweak it so it works. So yeah, that's pretty cool. But the flip side is that that's it. Yeah, the flip side is basically if you want to have a blend mode that needs to access the pixels you're writing to, it sort of adds quite a bit of extra overhead, because you have to basically, yeah, if you're rendering to a screen and you need to read those pixels, you have to render that somewhere else, and at the end render it back. So it means that you always have to do one extra full screen render, which sort of has a hit on performance, but it is there and it does work if you don't mind that. Using blend modes in Pixie, super straightforward. Any sprite can have a blend mode set, so you literally just go my sprite dot blend mode, and then you pick a blend mode. In this example, add, which is definitely my favorite one. The cool thing is if the blend mode isn't supported in the browser you're using, Pixie will just sort of give it the default one, so it will just gracefully degrade. Cool, and that's that. So yeah, all pretty simple. Right, next part, numbers. So basically, the next thing I'd like to talk about is the quantity of things that you can get on screen using, webGL and Canvas. And the amazing thing about modern browsers is they're all pretty much hardware accelerated now, which is obviously a really cool thing. And it means that you can basically get way more stuff on the screen than you ever could before. And if you use it well, you got all this extra power, which means you can create some really eye-popping content for your clients or for yourself. Cool. So if you want to get lots of things on screen, like what's the best way? The short answer is basically don't use the DOM. It's really, really slow. Use Canvas or use webGL. To give you the longer answer, I figured the best way is I could explain a little bit on how we render stuff with our engine PixieJS. So Canvas rendering is basically super basic. You just use context set transform, and then you do context draw image. So we try to keep it as simple as possible. And I've got a little example of, I don't know if anybody just saw Yvonne's talk a moment ago, but he showed a bunny mark. I've got my own little one here. So this is basically Canvas. So like I say, it's just context.drawImage, context.setTransform. And if I sort of add a few to the screen, you see a few little guys bouncing around. But yeah, I think you can get up to about more than that. Okay, it's starting to slow down now. So that's about, cool. So that's about 5,000 on the screen, which is not bad. I mean, that's at 51 frames a second. And you can get quite a few on the screen, and that's probably more than enough to make a game or like a piece of content. But more bunnies, right? So how do you get more of them? The answer is webGL. So I'm sure a lot of you guys know what webGL is, because there's a lot of talk about it. There's a lot of talks about it here today. But basically, it harnesses the power of the GPU and lets you render stuff way faster than just using Canvas alone, but only if you set it up correctly. So webGL renderer in general, it basically it's much harder to learn than Canvas, but like I say, the rewards are there if you put your head in there. The learning curve's a lot steeper, and getting even just an image on screen is a completely different kettle of fish. So from a top level, to draw an image in webGL, you basically use a quad. So it's basically just two triangles, and then you put a texture on the triangles. And that's sort of the top level way of how you render in webGL. Cool, so this is the slow way of rendering in webGL, which is basically what you do is every time you want to draw an image to the screen, you just go image through the GPU, and you basically do a graphics card call to put it onto the screen. So this example here, you basically got 5 things being drawn, 5 graphics card calls. So yeah, obviously this is super flexible, but it means if you're drawing 1,000 things, you're making 1,000 graphic card calls, which is slow. Cool. Then you got the fast way. So this is basically batching. So what it does is basically you can wrap all your draw calls into one call if the objects share the same texture. So a traditional approach for 2D batching is basically you sort of create a sprite batch object, and you go, right, here's a sprite batch, this is the texture. Use this. So anytime you add something to that, it has to match the same texture, otherwise it won't let you add it to its container. So this is super fast. Like, this is the best way to do it. But the only problem is it's not very flexible. Cool. So this is the third way, which is basically the Pixie way. So I'll kind of run through it as it happens in real time. But the way it works is it will sort of render through all the objects in the order that they need to be rendered. And when it hits the first one, it will kind of go, right, cool. What's the texture of this guy? And whatever it is, it will put it into a buffer. And then it will keep going to the next object and look at it and go, right, does it have the same texture? If it does, it will put that into the buffer as well. And then it will go to the next one and look at it, does it have the same texture? And if it does, puts that in the buffer too. and it kind of keeps going through all the objects, adding them into this buffer as long as they have the same texture. And then when it hits an object like a little bee over there that's a different texture, it'll kind of go, all right, cool. So it'll know that everything in here is one texture, so we can batch it and draw that in one go. And then it'll empty it out, put the little bee in there, and then just keep going, go to the next one and go, right, is that the same texture? And if it isn't, then it will draw whatever's in there, put that next object in. And it basically keeps doing that until it gets to the end of all the objects that need to be rendered. And the cool thing is basically doing it this way means you get the flexibility of this one, but the power of this one as well. The only extra piece of overhead is you have to check each object if they actually have the same texture before rendering them. But it's it's pretty negligible. Cool. So yeah, and basically in Pixie, this all happens behind the scenes, so you don't have to really ever worry about batching and stuff. All you have to sort of worry about is making texture sheets, sprite sheets, because that's basically gives you a really good performance boost if you can get everything on one texture, because then you end up with bigger batches. Cool. Okay, so even faster. The cool thing, we were basically working on Pixie, and we were like, can we make it even faster? Could we squeeze even more performance out of the computer? So we had a look to see what we could do to actually sort of speed up batching even more. One thing we found is that the CPU tends to be the place where things start to slow down. So we were wondering if there's anything we could move more of it to the GPU. And this is basically the update transform code in Pixie. So it's a bit of matrix maths. Nothing too crazy, but this gets called on every object every time it gets rendered. So we were wondering if we could move that to the GPU. And the good news is, we figured out a way. So basically, what we do is basically for the four corners of the quad that we're drawing, instead of sort of transforming those points and going, right, this is where the points are, what we do is with each point, we also upload its scale, transformation, and position into the buffer as well. So it means that the GPU then can take that information and calculate where it should be on screen. The funny thing is it basically has to do it 4 times on the GPU, but because the GPU is way more than 4 times faster, overall it works out to be pretty speedy. Cool. Okay, so that was the 5,000 bunnies in Canvas, and let's go to webGL one. Okay, cool. So that's 10 bunnies. All right, that's 5,000 bunnies and webGL. So already it's like faster. But if we go to more bunnies, all right, cool. That's 20,000 bunnies. Not enough though, right? 30,000. It's not enough. Okay, all right, there's 50,000. Starting to drop a frame. Let's keep going. Okay, cool. Blimey. Okay, this is actually faster than it's ever been before. Okay, we're starting to get some slowdown now, but I'll keep going anyway. I'll get it to 30 frames a second to see how many bunnies we can get on screen. Okay, that's 100,000.
I think your laptop's going to run out of battery.
Yeah. 120. Okay, we're in 30s now. That's going to keep going. Okay, nearly there. Okay, that's 150,000. More. Okay, 31. Okay, cool. There we go. It went to 29 just then. Okay, that's 160,000 bunnies, which is yeah. There you go. So the important thing to remember with all these bunnies as well is that they're all individual objects. They've all got their own rotation, scale, alpha. The only reason they look sort of all uniform like that is just because it looks better. So it means that hopefully that's enough to make a game or something really cool. Yeah, all right, sweet. So what's next? No more bunnies. Okay, cool. So the next thing I'd like to talk about is fun with shapes. So, like I said before, to draw something in WebGL, you basically use two triangles. But what if your texture, had more than, what if you used more than two triangles? Say you use like, 10 or like a big line of them. What could you do with that? And, there's quite a few things you can do with that. So, I'll show you now like one of the cool things you can do. So, if you imagine a line of points, and then imagine that these lines of points can then be sort of bent and moved around. Imagine that you're moving them around with some physics or some tweening or some whatever floats your boat, and then you take these points and you extrude them out with a little bit of maths. So as they bend and move around, they always kind of stay perpendicular to the center point, and then you take those endpoints and you convert them to triangles. So you end up like this. This is obviously from a GPU point of view, you've obviously got here, you've got vertices now and you've got your triangles, so it's nice and friendly. And then the next thing you do is you texture that with a little snake. And and then put some code in there so that the little snake, you can move these points around. And the idea is that the points move around, but the texture stays mapped to the triangle. And what you end up with is, oh, not that, can't look at that yet. Snake. There we go. Little snake, he looks like he's really got to be somewhere. Cool, so there you go, wiggles around, and it's a bit more interesting than, bam, there's an image on the screen, bam, there's an image rotating. It's just like, brings a little bit more life to it all. Yeah, cool. So that's one example. I've actually got like I did this before one time, so I can show you a little example that's a little bit more, I really should get rid of that. There we go. So this is like a few more of the same sort of thing, like tentacles, but this time we attached some Verlet sort of physics to it. So basically, you can see here, you kind of move my mouse around, and it kind of reacts, kind of cool. I can actually add a few more tentacles. There we go. Whee. Yeah, so a bit more, like I say, a bit more fun than just slapping an image on the screen. You can see blend modes in action there as well on the little fishes. And so obviously, in WebGL, this is super fast, and this is, WebGL is the place to do it. But you can do this with Canvas as well. So to do it with Canvas, you basically, you need to use clipping and make sort of a bit of matrix maths to sort of calculate how a triangle should be drawn. I mean, it's certainly a little bit more CPU expensive, because you basically, you have to draw a triangle, and then that's a mask for a texture that you have to draw, which is then got a matrix applied to it, which you have to calculate, and the maths of that's quite heavy, but it is possible. And I'll show you this snake again here. You're gonna have to sort of trust me on this, but this is actually Canvas, but it looks exactly the same. So the cool thing is with this little guy is it runs on your phone, which is nice. Yeah. So the way we do it is actually really similar to how we used to make 3D stuff back in the Flash days before they actually had Stage 3D. So again, just drawing triangles and manipulating them. Cool. And the one way to get good performance for shapes in Canvas is basically just get rid of the texture. I know that sounds a bit lame, but there's lots of stuff you can do with just flat shapes, which is actually what this little guy's all about. So this is basically a website we made at our company. It's like an infinite grid, but internet's a little bit slow, so it takes a while for these things to load. But anyway, the point is, this is a grid with a bunch of sort of springs that connect all the squares instead of just sort of going, oh, here's a grid of images. We were like, all right, cool, let's have a little bit more fun with it and use shapes to give it kind of more of a springy effect. And again, because there's no texture, there's no texturing involved, and it's just sort of doing flat color fills, it means that it runs really well, and it runs on like your iPad and mobile devices as well, which is kind of cool. Okay, sweet. So I can close that now. Actually, can I click on one? No. Yeah, the internet's a little bit too slow for this site today. There we go. I'll get rid of that. Yeah, so there they go. CPU hungry. Cool, okay, right. So moving on, the next thing I'd like to talk about is filters. So most of you know what these guys are. basically they're the secret source of 2D. And Photoshop, if you use Photoshop, you've probably been using them for a while. And if you've ever used Flash, you've probably been using them as well. So if someone asked me to describe what a filter was, I'd basically say it's a function or a program that you run on every single pixel in an image. So here's an example. The filter is now blurred. So basically what happened there was kind of that image was looked at. It went through every pixel in that image, looked at all the other pixels around it, got an average, and then sort of you end up with this sort of blur effect. Right. The thing is with this is basically this is really CPU intensive. Traditionally, this is all done, like I say, on the CPU. So what you have to do is go through every pixel. So if you imagine a 1024 by 768 image, that would mean that you'd have to loop through. I've got it here. 786,432 pixels. So imagine running that on every pixel, every frame. It gets really, really intense. So how do you fix that problem? The answer is basically webGL again. So basically it will come to save you because it's basically got a wonderful thing, which is the shaders. So where am I in this? Cool. Yeah. Okay. So a little bit of top level on webGL programs. I'm not too sure how much you guys know about them, but they're basically written in a language called GLSL, which is really similar to C. And you create them and then you upload them to the GPU, and the GPU runs them, and it runs them super fast. That's basically hardware acceleration in a nutshell. Basically a program consists of two parts. Vertex shader, and the purpose of that is basically it gets run on every single point that you upload to the GPU, and that's that bit. And then you've got the fragment shader, which is basically once it's drawn a triangle, it needs to sort of rasterize it and draw the actual triangle itself, and that's when the fragment shader gets run on every single pixel in that triangle. Cool. And basically this is exactly what we need. It's like, okay, we want to operate on every single pixel, so we just basically write neat custom fragment shaders that let us use filters. Cool. And obviously the GPU is really fast at doing this, so you can get it in real time. And I've got an example of some filters. A filter here. This is the color matrix filter, or the rave filter, whichever one floats your boat. Yeah, so there we go. It's basically every frame, every pixel is getting multiplied by a matrix. And like I say, no slowdown, runs like a boss. There you go, I can switch it off, but it's more fun on. Okay, cool. So, right. So I figured it might be good to explain how we do filters in Pixie. So obviously, there's an image and then you run a filter on it, but with Pixie, the cool thing is it's kind of a bit more similar to Flash. You could basically apply a filter to anything in real time. So it might not be a sprite, it might be a container with like loads of sprites in it, with more containers and more sprites in there. So it's like, how do you sort of filter that in real time? The way we do it is basically, say if you imagine you're rendering again, so say this scene here, imagine this pink fish and this yellowy fish in the same container, and you've put a blur filter on that container. So Pixie's rendering all the objects, and then it hits this container and goes, all right, there's a filter on that. So what it will do is, instead of rendering the fish to the main scene like it normally would, it'll kind of look at it and do a bit of maths to go, right, how big is this object? And it'll say, so it'll calculate how big it is, and then it will create a little texture off screen. And then instead of drawing the fishes to the main scene, it will draw the fishes to that off-screen texture. And then we know it's going to fit because we calculated the size of it. And once it's finished rendering the fishes, it then goes, right, cool, I'll take that and then put that on, draw that onto the main scene. And at that point, that's when it does it using a filter. And if you have a bunch of filters on there, then say you've got like 3 or 4, what it'll do is it'll take that texture and it will draw it to another texture with doing a filter pass, and then it will draw it back doing another filter pass, and it'll keep flip-flopping it between 2 textures until the final filter pass, and then it will bam, draw it into the stage. Cool. Okay, so yeah, that's pretty much how it works in Pixie. And we've actually made quite a few filters already in there, which obviously you can all use. Yeah, so I guess I could show you that in action. So these are more fishes. Cool. Okay, so in this scene here, there's basically fishes, and they've all got like a displacement map filter on them at the moment. So basically all that is there's another texture which sort of offsets the pixels, but there's more here. So here's a blur filter, here's a pixelate filter. I'll sort of go through them all. Some of them are a little less interesting, like an invert filter. It's a bit safe. A grey filter. And they're all like, all tweakable as well, so you can sort of have 50% sepia if that's what you fancy. Twist, this one's a little bit more fun. So you can have a cool twist effect. Dot screen, so this makes it look a bit more like a newspaper. Always useful. And then crosshatch, this is a bit of a weird one, but it's kind of cool. So yeah, and then the good thing is basically the way it works is you can stack up filters, so we can you can have them all happening at the same time. And again, there's a lot going on, but it all happens in real time. But computers are really fast these days, so it just doesn't really slow down. Cool. And how do you use all these wonderful filters? It's super easy. Basically, in Pixie, you just go new blur filter, and then every single object has a filters property, and all you have to do is give it an array of filters, and it will just render them. So you don't have to worry about any of that stuff I talked about. It just will work, which is good because it's very complicated. Okay, cool. Right, so the next thing I'd like to talk about is normal mapping. So for Pixie, from Pixie point of view, this is basically just a sort of a custom filter. But from the real world point of view, it's like a sort of an old school technique that's been around in the 3D world for ages. It's basically a really nice way of sort of making simple. Basically, it takes complex geometry and you can then make sort of simple geometry, and it kind of gives the illusion of more detail. And it's good for sort of lighting and stuff like that too. Yeah, and it's been in the CGI industry for many years. And like I say, the reason I want to talk to you guys about it, because even though it's a 3D technique, as it turns out, it's pretty awesome for 2D too. Cool, so there we go. This is a normal map. I don't know how many of you guys have seen normal maps before. All right, cool. So you all know how they work. Brilliant. Okay, well, I'll give you a top line for the people who don't. Basically, this is basically a normal map stores the spatial direction of every pixel. So in a spatial direction is basically an X, Y, Z coordinate, and conveniently in an image you've got your RGB. So all it is basically you just map the X, Y, Z to RGB, and then you end up with a really rainbowy looking texture. The reason you get mostly blue as well is because that's X, Y, Z of, like, it would be like 0, 0, 1, so it'd be like the Z is looking at you, and that's the direction of that pixel, which makes sense, right? Because RGB, like, it would be 0, 0, 1 would be blue, so just the same as X, 0, Y, 0, Z, 1. Cool, so basically with this information you can then sort of determine how bright or dark a pixel should be based on the light source. And once you mix that in back with the original texture, you end up with something that looks pretty cool. So get rid of this crazy example. There we go. Cool. So this is basically normal mapping in action, and again, it's just done from like 2 textures, and it's really super efficient, and it's just kind of like a nice little effect. Again, that's a little bit more than just bam, here's an image on the screen. Yeah, so it would be my dream to actually make a game which is entirely sort of powered like this. I mean, I haven't had the opportunity yet, but like you can imagine if you made something that was like lit like this, like be a real head-turning project. Cool. Okay, so you can basically make normal maps from. There's a program called Crazy Bump, which is what we often use, but there's also loads of Photoshop plugins as well, which will help you out. Cool. Okay. Okay, so the last bit, putting it all together. So I thought I'd show you one more example. It's a little bit out of season because it's basically a Christmas cracker, and it's not Christmas anymore. But I thought it would be a good one to show you guys because it basically has a few of the things that I've talked about today. So it's basically got a bit of triangle mesh in it. It's got some filters in it. It's got, what else has it got in it? It's got some, yeah, it's got filters, triangle mesh, and it's also got like, lots of stuff on the screen as well. So I figured I could show you that. Like I said, a little out of season. Turn the music down. Cool. All right, there we go. So this is the cracker. So that whole thing is basically a triangle strip, and I can sort of pull it and wiggle it around. And it's basically nice and springy. But yeah, that cracker is basically just a bunch of triangles. And like I say, they just get manipulated by your mouse. And these little ribbons as well, they're basically the same thing, but they've just got a bit of gravity on them to pull them down. And yeah, I mean, do you guys know Liechtenstein? Like an artist, yeah. He's all into the old pop art thing. So it's a bit subtle, but the background, like the shadow and the sort of I forget what it's called. The sort of tone at the bottom is basically that's a filter. So like as I stretch it, you can see there's a bunch of dots that make it up, but they don't actually stretch with the cracker. So they kind of kept to look as dots because that was kind of how we were going. Yeah, cool. So when I pull it, there you go. So yeah, you can see the other bits that we put in there. So tons of little things exploding. There's like 3,000 or 4,000 things just going out of there. But like I say, because it's batched, you don't get any slowdown at all. This whole thing runs at 60 frames a second. The other thing as well is a displacement map filter, as you can kind of see it rippling out. Yeah, so that's basically all of the stuff I've talked about in action, basically. Cool. Why 2D is awesome? Because reasons. Basically, yeah. So 2D is basically awesome, and why we're like at Goodboy we're massive fans of it is basically with 3D. 3D is amazing, and we do love a bit of 3D, but it's not as viable just yet because if you make something in 3D using webGL, your clients are a little bit more hesitant because the penetration of webGL isn't quite there yet. I mean, you've always got like your trailblazers, right? You've always got like Nike and Red Bull who are smashing out amazing 3D websites. We would love to do that, but in the world we live in, it's like we can't offer that to a client because they'll be like, no, only like 60% of people are going to be able to view this site. But with 2D and WebGL and Canvas and all this stuff, we basically get to have our cake and eat it. We get to like basically throw the kitchen sink at it. We get to put all these cool WebGL filters in there, loads of crazy, numbers, loads of really cool stuff. But we can always fall back to Canvas if it's not available. So we're really careful about how we design stuff. We won't make something that has to be WebGL. We'll make it something that like will work in Canvas. But if your user's got WebGL, then we can throw the kitchen sink at him, which is good for us because it means we get to try and test ourselves and make some really cool stuff that we can show all you guys and be proud of. But we still get the happy clients because it means that it will work on an iPad or a mobile phone. Also today, I don't know if you guys heard, but like there's rumors going around that Apple might actually enable WebGL on Safari like properly within the next few days at one of their conferences. I don't know how true that is, but it's got us very excited. Bit of speculation. Cool. Okay, sweet. Well, that's the talk. Oh, perfect timing. Cool. Okay, well, yeah, that's it. Done. Thanks. So, yeah, thanks for putting up with my ramblings for the last half an hour. If you want to know more about us, you can check out goodboydigital.com/blog. Pretty much, we'll try and write up anything that we discover or want to share on there. I tweet a lot, so if you want to follow me, it's Dormat23 on Twitter. And if you want to get your hands on Pixie or the source code, you can go over to GitHub and go to goodboydigital.com/PixieJS, and yeah, it's there. It's free. Like people have started using it now, which is really exciting. There's also actually a Pixie website, PixieJS.com, so you can see what other people have actually made of it rather than just ourselves. But yeah, that's it. Thanks very much. Cool. Any questions?
So, how do you guys handle things like zooming combined with screen resizing and like all that kind of stuff? Does PixieJS handle that? Or?
Not really. We figured that kind of stuff is user responsibility. like our like, you know, sort of defining the boundaries of what Pixie is basically that will put stuff on screen, and we'll try and do that as well as possible. Like resolution, you know, size of space. It's like we think of that as like a user, you know, user responsibility. I mean, for ourselves, whenever we use it, we basically, you know, we have our little system for coping with that. But like I say, we want to keep Pixie super light so people can go, oh, cool, rendering, we're going to use that, and then they can build their own systems on top of it. But yeah.
Pixie's free, right?
Yeah, man.
What's the monetization?
None. Basically, okay, well, our agenda was like I say, we're a new company. We've only existed for a year, and what we wanted to do when we sort of started it, we were like, okay, right, let's create some notoriety for ourselves, and also we needed it because like we wanted to make stuff that, and there wasn't really, you know, we wanted to make stuff in WebGL and Canvas, and it just didn't really exist. So yeah, we made it. We wanted to give it out for free, and it's sort of it's paid us back in, you know, in various ways. It means I get to stand here in San Francisco. Obviously, you can tell I'm not from San Francisco, so like, you know, little perks like that. But other than that,
a ton of contributors.
yeah, exactly, and you know, it's spawned like a, you know, there's a community now. Like it's just awesome to be part of it, man. Like it just makes you sleep at night. It's like, oh, cool. People are using, you know, every time someone like launches a product and it's like, oh, that's Pixie powered. You're just like, oh, sweet, awesome, you know, like, so it's worth it just that. But like at the same time, it has raised our like, you know, notoriety a little bit, and, you know, means that when we go and talk to clients, we can be really confident. Sometimes we can walk in there and go, you use our technology already, and it's just like, sweet. But yeah, it's not, you know, we got no plans to monetize it. We don't really know how we'd monetize it. It's just you know, everybody wins from it kind of thing.
How do you handle text across 2D?
We basically have bitmap. You can use bitmap fonts, so you could you basically just save them out as a sort of a sprite sheet. There's software that does that for you, but other than that, we just use a canvas. We just create a little canvas, draw some text to it, and then upload that to the GPU. So basically, if it works in Canvas, it'll work in Pixie, because most of the time you don't really frequently change text that often, so it means that the text just stays up there. But even if you did it, it's not that much of a hit unless you were doing it like thousands of times each frame. Cool. Done?
One more.
Go for it.
The filters and shaders, what happens when you're on Canvas?
They just don't work. Yeah, they just don't, you know, don't work. So everything will be there, but those filters just won't be. We sort of toyed around with filters in Canvas, but it's just not worth it. It's like, maybe like, I don't know, not real time. It's totally not worth it real time. So we just sort of just move away from it. It's probably the biggest difference between WebGL and Canvas. They're pretty much identical, apart from Canvas has more blend modes, WebGL has filters. Like, that's the only sort of difference between the two. Cool. Done. Thank you.